Also, now you have to read down.
Nice.
Working? I have no idea.
Yeah.
I hope it works.
No progress.
Oh, yeah, the meeting for perfect.
Where's your deal? There's not.
Honestly, like, can I just speedrun CRTO? Like, I'm gonna get at it.
That's really helpful.
Yeah.
We'll give it another minute.
Like, oh, shit, are you?
Yeah, I bet you. Pretty sure it's midterms, and I was like, I don't like. Playing that they're being.
Depends on the market.
But more fun when they're all time, like.
Some of them?
Yeah.
I need to ask Joe, like, what it's all about, you know? He's already got it.
So I think UBS just does the same.
So where are you right now?
I don't remember.
Like our business.
So they just got like.
They like to encourage.
All right, I'm assuming everyone's signed in by now.
Not to put in production because it has like a console and stuff. So like, if you put it on.
All right, so I'm gonna start the meeting right now. So as you can see, we are right about ready to have RVB. Today, we'll be talking a little bit about some important stuff like scoring, accessing the environment, injects, and at the very end, we'll have a bit of a sneak peek of the actual environment. Friday will pretty much be an expansion of this meeting. At the end, it's going to be a very, let's say, a primer to something very important about the environment, and you'll be practicing that on Friday. So as you can see, first accessing the environment stuff, second injects, and then finally a sneak peek. So it's kind of important to have credentials for the environment. However, we will not be giving you these until the day of the competition. These credentials will be used for both accessing the scoring engine and accessing your machines on the environment via ELSA. Yeah. If you don't know how to access ELSA, you can look at the Camino guide inside of Discord, I believe on the workshop channel. The Camino guide can be found there. Just skip steps 2 and 3 since that's how to make a Camino VM. You just want to know how to connect to the VPN and access ELSA itself. As for more important things, scoring. This is a new scoring engine by Gabe. Shoutouts. And right now it's not accessible, but later on, nearing the competition, you'll actually be able to access it at https:/scoring.calpolyswift.org. If you were able to access it and log in, this is what you would see. It's a very nice looking UI. On the very left, you can see stuff like announcements, scoreboard, which I do not believe we are going to be having available to you guys. The overview, injects, and PCRs. We'll explain each section in a little bit. Obviously here we have the announcements. This likely will not be used since I think we're just going to ping you guys on Discord. Next, we have the scoreboard. The scoreboard shows you what services are being scored, whether or not they've succeeded or failed, the uptime that services had, and more. As you can see, it displays the 8 most recent checks for all of the checks. And while there is a section at the bottom called SLAs, you can just ignore that. Normally SLAs would punish you if you fail X amount of checks in a row. However, we're just going to be disabling it for this environment. And if you look at it right there, you may be able to get a sneak peek of what's in the environment. You'll see more of that later on. Next, we'll be skipping over injects a little bit since it flows better if we put it on the next slide. But here we have PCRs, or password change requests. Here is where you can see credentials that are being scored by the environment. So say you change the passwords to a Linux login for like SSH or part of Active Directory. But say scoring engine is trying to access that service, they're trying to log into it. If you change the credentials, obviously it's going to be using the old ones and the check will fail. So you have to submit some password change requests so that it can use the correct credentials. On the very left, that is where you will select which cred list you want to change. These will be aptly named so you understand either what service they link to or what scored service they link to or what general service they link to. So in this case, that might not be readable, but that says 80 cred list. So changing that would change the credentials of the users on Active Directory. And on the right, you can see the current state of the scored credentials. This conveniently shows you all of the users that they're checking. And that's important since if you don't put the right name when submitting a password change request, you won't change anyone's passwords. So please do follow the format from the state of the credentials. And finally, injects. Injects are intermittent business tasks that you need to complete. Here you can see the basic layout. I believe we'll be covering this more on the next few slides. So you'll see this image again. As I stated before, injects are business tasks that you must complete during a certain time. This sounds really simple, and it is, until you realize that you have to juggle this along with maintaining your systems and also making sure that red team doesn't get in and break your systems. That being said, you shouldn't just ignore injects if your services are down. They are a significant portion of your score, and so you should always try to complete an inject when possible. Some tips when trying to do an inject well: you should read the full inject. If you don't read the full inject, you might miss something critical that the inject is asking of you, thus leading to a loss of points. Next, you should mark down what's important for the inject. If you have to read the inject over and over, or if you're trying to explain to another teammate what the inject requires of them, say you have someone who focuses on Linux and you need something specific for Linux, you don't want them to have to read the whole inject. You want to be able to tell them, hey, we need this, this, and this. This needs to be done, and you need to give it to me so I can write it. Next, you should really mark down when the inject is due. This is quite important, and really you should mark down an earlier time than when the inject is due, since you'll be bombarded with this stuff along with your services. You'll want to finish it beforehand so you'll actually have time to write it in a proper manner, and so that you can actually submit it. Because otherwise you might not have time. Next, good formatting is important. You want to make sure it looks nice so it's easier for one, the graders to read, and two, formatting is a scored component since this is replicating something you'd give to a full business. They want it to look nice so that it's easy for them to read. And finally, like I said before, don't just ignore the inject. It's worth a lot of points. You need to do them. So like I said before, here's the inject page again. This time a bit more zoomed in. On the far top left, we can see we've selected an inject called test inject. It might be hard to see, but there is a green check mark up there as well. This means you submitted the inject. But for now, the more important stuff is the attachments, the due time, and the very bottom, your submissions. On the far left, we can see the attached inject. You'll be able to click on that, download it, and read it. Next to the right of that, we have the due time and of course the close time, but these will match, these will be the same during the actual environment. So you really just need to know one of them. This is when the inject is due. You should mark that down, and you should mark down earlier when you should have the information ready so that you can write it. And when you eventually submit an inject, by selecting at the very bottom, choosing a file, and then pressing submit. Then at the very bottom, you'll see all the injects you've submitted for this. You'll see all the files you submitted for this inject. This is important since you'll be able to download it to see, hey, did something mess up with the formatting when you converted it or something? Just to double check if you have the time. Here is an example inject you might actually receive. This itself isn't one of our injects that you'll be getting for this RvB environment. This is from WRC/CDC, but it's a pretty good example of something you might receive. So, what's important from this inject? What can you pick out from this that's important and not just fluff? No. Man, that is not easy to read. I guess I can read it out. Yeah. Let's see. Now, as you may know, there was a prior team that before you came in. There were quite a bunch of amateurs and never got any work done. Although they came on time to work every day, no work was ever getting done. I even caught them playing games on company resources. The nerve. Anyways, they were referred to HR, who sent them a recommendation to the company president. As you can deduce, they're now off to seek other business opportunities away from us. Here's what I need your team to do. Go through all the hosts on the company network and give me a report and on all unnecessary software you may find. After doing so, remove them. So, as we can see, parts of the inject are a bit of fluff just to set in, I guess, the lore of the environment. But that bottom part is what is actually important. It's asking us to, audit any hosts for unnecessary software. 2, document any of the unnecessary software you find. And 3, remove any of the unnecessary software or any software you deem unnecessary for the company to function. Crazy. And so here we have an example response. Here we can see we've addressed the inject at the very top. We're telling them, hey, this is for the unnecessary services audit. We give a brief explanation of what this inject is going to entail. You can't read that. That says attached below are tables detailing each host and the extraneous services we have found on them, or software, sorry. And that's exactly what we've provided them. We've used a bunch of tables, since tables are a very nice way of formatting this content. We've addressed all the hosts. While you can't really see it since I've cut it out, there are a bunch more pages to this that follow this same layout, so I just didn't show it. And finally, we've addressed the part where we needed to delete the services or the software that we found unnecessary. We show that with the status part on the bottom. That's mostly it for injects. So yeah. Any questions so far? I didn't really know where to put this slide. Here's just some other miscellaneous important info. If you ever need help in the environment itself, say you need to do something like a box revert, you can always ping the green team role in your own text channel. We'll try to respond to it as quickly as possible. Next, if you do need to revert the environment, box reverts are free. Please don't try to spam them, as that's not very fun. I don't think Red Team is trying to destroy your services, and in the same manner, you should be able to recover from it if possible. Or rather, you should be able to recover from it, provided you know how to do that. It shouldn't be just like, oh yeah, everything is gone. And finally, if you have any questions, you can always ping me. And if I don't know how to answer it, I'll try to redirect you to someone who does, or I'll try to get the answer from them. And finally, something you've probably been waiting for, a sneak peek of the environment. Just a bit of a heads up, this environment was cooked up by people who are very passionate about this stuff. They really wanted to make something that they could be proud to show other people, an environment that no matter your skill level, good or new or very experienced, you'll be able to learn something and take something away from it. It's something they wanted you to be able to talk about to, say, a future employer, or just anyone in general. This of course means that the environment is very, very complex, and I would say a bit difficult, especially if you are new. This is taking inspiration from WRC-CDC, which is one of the more difficult regions for the CCDC or Collegiate Cyber Defense competitions. Sorry about that, not explaining it. So who's ready to see the topology? Three, two, one. This is the topology. There's a lot of things on it. And I do want to point out some very important key stuff to this. First, at the very bottom middle, that says free EPA. If you're familiar with Windows Active Directory, it's pretty much a Linux equivalent. If you're not familiar with it, it handles stuff like authentication and user management, authentication to a bunch of different services, and access controls to that stuff. Let's see, what else did I write? Oh yeah, next, SSO. SSO, or single sign-on, allows a user to sign in to one account and then have access to a bunch of different services using that same one account. In this case, the SSO is something called KeyCloak. Just a heads up, if I remember correctly, this SSO is linked to both the Windows Active Directory and the Linux free EPA environment, meaning that if you can log into your free EPA, or sorry, the credentials used to log into free EPA are the same credentials you can use to log into KeyCloak, and the same is with Active Directory. Next, sorry, let me take some water real quick. Next, DNS. While it's not really shown here, other than Active Directory requiring DNS between a bunch of different services or a bunch of its own machines, DNS is very, very crucial to this environment. I believe all the records are on the .5 pepperoni. But it is taking some of the records from the Bucatini/free EPA environment. The reason why this is so important is scoring engine will be using your DNS server for checks to work. If you do not have your DNS server up, prepare to see a lot of reds. Next, I guess, there is a trust between the Active Directory environment and the free EPA. So users from one environment say the free EPA Linux domain, can authenticate into the Active Directory domain. And if I remember correctly, permissions like administrator and root do transfer over between the environments. You can thank Dylan for that one. You can thank Dylan for a lot of this mess you'll be dealing with. He cooked up the bottom part and was very happy to make it in 3 hours at like 12 to 3 a.m. And finally, something we'll be talking about today and the Friday workshop. On the bottom right, if you can see that blue icon, that is Kubernetes. This will be very hard to explain in a very short amount of time. So rather than, I guess, trying to explain what Kubernetes is, at least during today, I will try to give you a primer as to why Kubernetes exists. Why Kubernetes exists, and hopefully build up some information that you can then use for this Friday workshop, where you will be hopefully creating a bunch of different services or you'll hopefully be setting up a bunch of different services, first on machines itself, then containers itself, and then finally onto Kubernetes. We'll explain all of this on the next few slides. Oh, also on the bottom left, Jacob decided he wanted to make a AI chatbot. So yeah, something pretty cool. So why exactly do we need Kubernetes? Let's go to some basic application deployments. So say you have just a random Linux server and you want to spin up some random web app like WordPress. WordPress, if you're not familiar, requires a web server to actually host the application itself and a database. So you install all of that on one machine, and say now you want to install a different application, say a Flask app on this. Say this requires a different database like Postgres instead of MySQL. Now you have all of those running on the same machine. All of them running directly on the same machine. Rather than running them directly on the bare metal or just the machine itself, you can instead decide to containerize each individual component so that they run in their own separate environment. So traditional deployments for bare metal services involve running that stuff again on the physical service itself. So like I said before, those apps would be stuff like the WordPress app, the Flask app, etc. And the required components like MySQL, Postgres, databases, whatever. Any components that are necessary to get that application up for your customers to access. While running this stuff directly on the machine is fairly quick to deploy and easy to understand, there are still some caveats with running it directly. For example, if one application is incredibly resource hungry, it may starve other deployments, other applications from having the necessary resources to run. Next, running them all on the host itself means there's no security between the applications, not to mention between the host and the application itself. If, say, someone breaks into the Flask web app because someone left debug mode on, they're not running in their own isolated environment where the application is running. They're now running some malicious code, malware on your host, something that you really don't want to happen. Let's go over a quick example of how we might install something like WordPress on a bare metal virtual machine, on a machine itself. So WordPress requires 3 things, kind of 4 if you count the operating system, but whatever. It requires a web server, a database, and a scripting language called PHP. So the process goes, you need to install the dependencies, Apache, MySQL, PHP, and all of the random stuff that goes along with it. Next, you need to set up and configure that MySQL server. And finally, you need to configure WordPress. A very quick and simple process. Here we can see me installing the MySQL stuff. I didn't really show configuring or not just the MySQL stuff, but all the dependencies, Apache, PHP, and MySQL. I didn't really show configuring the MySQL server, but that would be just creating a database and then setting up a user to actually have permissions over that. And then configuring WordPress is going to the web GUI and just following the instructions. So pretty simple stuff. And this really does show how easy it can be to run stuff on a machine directly. Now, we compare this to running stuff in its own isolated environment, aka containers. Rather than running those services, MySQL, Apache, rather than running them directly on the machine itself, we can bundle them into their own individual components so that they're isolated and can run wherever they want. Containerization is incredibly important. It prevents, or rather, it keeps these applications isolated. So let's go back to when someone broke into that Flask app. Now, instead of being on your bare metal host or your machine, they're now in their own isolated environment. So that provides a layer of security. Next, containers are more portable than trying to just run the stuff on the machine. If you've tried to install WordPress or something on a super old system compared to a super new system, you might have some problems if you're following the new instructions compared to the old one, since stuff will change. Your environment will change. Containerized stuff are run in a consistent environment, so you can bring them from either the laptop, you can run them in stuff like a laptop, a machine, a cloud, in a very consistent manner. And finally, you have more efficient resource utilization. If we go back to, say, the running stuff on the machine itself, if you wanted to prevent applications from being able to interfere with each other, you might have the idea of running each application on a separate server. While yes, you can do that, and that would prevent one application from interfering with another, you still have the issue, or you now have a different issue of you're likely not using all the resources on both machines, and now you're kind of just burning money. Let's talk about something to facilitate this containerization. Docker. Specifically, the Docker engine is software, containerization software that allows you to manage and build containers so that you can run these applications in an isolated environment. There isn't too much to say about this. It is much nicer to do this yourself. So again, a workshop will be nice, but I do have a quick demo on the next slide. Again, we're going to go with the example of WordPress. The process for this with Docker is a bit different. First, you need to pull down the containers. They're on a public registry, which is like a repository of a bunch of different containers that people have made that have this application in an isolated and consistent environment. Next, you need to run the MySQL container, and be able to access it to modify the database so that modify, and configure the database so that WordPress can use it properly. Next, you need to run the WordPress container since, you kind of want an application to use that database. And in this case, we chose WordPress. And then finally, similar to the last step, you need to configure WordPress. To the left, we can see me pulling down the containers. And on the bottom, we can see me running the WordPress Docker container. This will be stuff you'll be going over on Friday, so it's not too important for now, but yeah. As we can see, the steps here are a bit more complicated. There's a bit more involvement in actually getting this stuff set up. But when you do this, all of this will be in, all of the components needed to run WordPress will be run in an isolated environment. Sorry. Excuse me. So containers are very useful, they're nice, but there are still some things we want from containers that just Docker alone doesn't have. Say we want to scale a container deployment for maximum resource utilization. Say you have one WordPress application running in a container, but you're getting a lot of traffic to it. You want to be able to scale up that WordPress container to have more, or you want to be able to scale the amount of WordPress containers you have to adjust for network traffic. You obviously don't want to just have like 10 of them, since that's being resource efficient, but you don't want only one, since then you might end up getting DOSed on accident due to too much network overload. Next, if one of these Docker containers fails or gets modified in a negative way, you want this container to be automatically recreated. You don't want it to be running on the environment and giving your customers a negative experience. And kind of like what I said with the first one, you want to be able to balance traffic between multiple different containers. If they want to access an application, you want to be able to spread them out between multiple different containers so that the traffic between one container isn't overly high. That's where Kubernetes will come in. Kubernetes is a system for automatically deploying, scaling, and managing a set of containers. You can scale stuff depending on the amount of resources being used. You can recreate pods to maintain availability, and you ultimately define this stuff via just simple YAML files. The reason we want Kubernetes is it helps increase resilience and availability. However, unfortunately, Kubernetes gets complicated. This is actually a bit of a simple Kubernetes diagram. It's missing some features. And Kubernetes, I don't believe, is something I can teach you within the next 10 minutes. And personally speaking, how I learned it was just by messing around with it, getting help from Dylan, taking his stuff, modifying it. And so that's something, Kubernetes is something I believe is better learned just by doing it. You do want a bit of an explanation of this. The left client is accessing a service on the Kubernetes system, the Kubernetes environment by accessing the load balancer, which points to a service so that the client can be sent to a container or sent to a pod that isn't overloaded by other traffic. It gets a bit complicated, and if you didn't really understand the the terms I used there, that was kind of the point of that sentence. It's not something I don't believe I can teach in a very quick manner. And so I believe this is where I will leave it off. I would have added an extra slide showing that there are some things that help help deploying Kubernetes. It helps makes Kubernetes deployment much easier. Something like K3s and Rancher. This is a very convenient and lightweight software that manages Kubernetes systems or Kubernetes clusters. Evan brought up a very funny explanation of its naming. So, like I said before, Kubernetes has the ability to kill pods that are not functioning properly. This is similar to an actual rancher, where if your cattle is not healthy, they're not making it out alive. We have tools like Rancher and a bunch of other abstractions, especially in the cloud, like I don't want to say EKS. I believe not Amazon, Azure's Kubernetes software. I don't remember what exactly it is. AKS, I believe, Azure Kubernetes Services, whatever. There are some abstractions to Kubernetes that make running it easier. So there is that benefit, but it's still a rather complicated system that I cannot really teach within this short amount of time. Unfortunately, I believe this is where I'll cut it off. Any questions that I might be able to answer? You guys excited for?
I was gonna ask, where can we find the slides?
Um,
I don't see them on the link tree.
that is crazy. I will,
You can put up.
like just,
I also don't see the sign in on the link tree.
also crazy.
That is correct.
Sorry, I did this at like
If you like that.
4 a.m. last night.
This is the first slide.
True. Sorry, I did this at 4 a.m. last night. It's very fun.
Like earlier than.
Bro, we had a long weekend this fun.
Yeah, it was a busy
Yeah, you
weekend.
did.
Shout out to CCDC, WRC CDC for making my week miserable.
Miserable.
Wait, we had a good weekend. What do you mean?
You had a good weekend.
Not
after
that
9 a.m.
Sunday, or not that Saturday.
Not that
That
Saturday,
was, the suspense was not fun, to say the least. We had a good time, I will agree. Very fun competition,
that's all you have to say.
yeah. I don't think red team will be deleting your stuff minute 1 for this environment, so, yeah,
Hopefully not.
hopefully not. Okay, any other questions?
So we have to know how to deploy Kubernetes.
Kubernetes will be, I believe for this workshop, I'll have it set up. I'll probably throw in instructions if you really want to figure out how to set it up, but I believe we'll be using K3s. We'll have it set up for you, and you'll just need to figure out how to deploy stuff on it. Installing Kubernetes or K3s is quite simple. There's just a bash script they give you, which is very nice, very convenient. I'll show the topology again, why not? Just in case anyone is curious and has any questions on this part itself. You will be receiving this topology in the briefing packet and other things. We will be giving you a lot of information on it since it is quite daunting, to say the least.
You have to like commit it over there. Yeah. Yeah, that's like.
Yeah, if there's no further questions, I believe I will end the Zoom recording. How do I do that? Where is stop recording? That's great.
Yeah.